So, welcome to the third episode of What Sex Got to Do with It. I'm here with Heather Remoff, the author, and she is my favorite great grandmother in Arlington. And so we're on to chapter 2 because we started with the acknowledgments, and this chapter is called Why Now? And so do you want to give maybe a little explanation for why that title to the chapter?
Yeah, the chapter actually, why did I write this book now, is I suddenly became so concerned about climate change. I have great-grandchildren, as you mentioned, and climate change, the concern about how rapidly a climate apocalypse is approaching made me think, Heather, you have ideas about our human species-specific traits that if we could employ them, we might be able to design policies that could address climate change. And so I had that sense of a mission. That's why I wrote the book now. Now, why now in terms of Darwin? Hundreds of books have been written about Charles Darwin, but I'm very, very much aware that his theory of sexual selection, which was outlined in his book, The Descent of Man and Selection in Relation to Sex, that his theory of sexual selection is in need of a serious, serious update. It's not accurate.
I understand. But so that's why now the book.
Yeah.
But the chapter, was there a specific reason for why you called chapter 2 Why Now?
Yeah, in part because why does this matter now?
Okay.
And one reason, in terms of the way men and women relate to each other on a very small, personal level, not everyone is completely happy with how their relationships are going. And then zoom out to the larger picture is I am concerned about climate change, and I think it's time to take a second look at Darwin, which, as I was explaining to you earlier, I think is really hard to do for a reason that I just learned about, a term called anchor bias, which means that the first thing we learn about a subject gets lodged in our brain, and it's the most difficult bias to overcome. And everyone has heard Darwin's theory of sexual selection presented in a way that I don't think is an accurate description of how sexual selection really works, and so I'm eager to update that.
Right. And to emphasize me, the book is called What Sex Got to Do with It, and I love that you just used the phrase zoom out, because I did want to compliment you on a great piece of writing, which was on page 27 of the manuscript, because I read the manuscript and not the book, and it says, consider our sense of economic security, or more accurately, insecurity. It is perhaps only individuals in the wealthiest top 10% who express satisfaction with their status. Zoom out, which you just said, move from the personal to the global, and consider the worldwide increase in inequality. Now, raise the curtain on the Anthropocene. I thought that was just a great piece of writing.
Oh, thanks.
To zoom out, and the raise the curtain. And so you definitely have a flair when you write. So now I think it's going to be the heart of our discussion of this chapter 2, and you talk about how women, when you talk about, you mentioned how you had talked to, I guess, 66 women, and you said that, none of them, or it's very rare that a woman would have sex with a man unless they dine out together. And you relate this to how the courtship is a part of the sexual selection, or at least the sexual selection process, and food courtship seems to be one of the most important or most common elements of courtship, and so I found that intriguing, and so I guess it's because food is just so important to survival.
To survival.
Right.
Len, I'm fairly certain that I'm the person who documented courtship feeding in humans. It's been acknowledged by biologists in all other species. I mean, a friend recently sent me a photo he'd taken of a male cardinal feeding a female cardinal sunflower seed at his bird feeder. And that's courtship feeding in birds. And we've always acknowledged that courtship feeding exists in other animals, but it's not been documented in humans. And you can say, well, of course, you know, part of the dating scene involves going out to dinner together, but it really goes beyond that culture, although that cultural having a meal together amplifies it. When I was interviewing these women, I didn't take notes, and we just did open-ended discussions. I asked them to talk to me about the men in their lives, how they met, what traits made them attractive, and women will talk about the men in their lives.
Of course.
Those interviews ran from 3 to 5 hours in length, and it was all on the tape recorder. I didn't type at the time, so I paid someone to transcribe my tapes. And in one of the last interviews, I was at the very end, and the woman described her husband as the sexiest man alive, and I thought, wow, that's pretty high praise. I said, what traits inspired you to give him that description? And she was so embarrassed. She couldn't think of things. She kept saying, oh, I can't think. Oh, wait, give me a minute. And then suddenly she looked up and smiled and said, oh, I know. He brought me 2 fresh pineapples. And at that moment, I pictured courtship feeding in other species, where the male's presenting the female with a gift of food. Now, I had coded most of my interviews by then. I'd gone through and color marked various traits that women described, and had, was coming up with profiles, but I had nothing in it about food.
Right.
And once she had done that, I went back through all my old notes, and discussions of food were everywhere, but it wasn't just, oh, we went out for dinner. At the time that they were telling me, I thought, oh yeah, it's nice that you had the shrimp scampi and a Caesar salad, but I kind of stopped paying attention, but the tape recorder was still paying attention. And those descriptions of meals that might have occurred 20 years before, the significance of them were, that was the meal they had together, or what he fed her immediately before they had sex for the first time. So it was very, very much tied to that, to sort of a reproductive intent. In fact, when I wrote my first book, Sexual Choice, one of the men's magazines did an interview with me around Valentine's Day, and the hint that I gave was, if you've only $5 to spend, don't spend it on flowers, spend it on food. Okay.
Interesting.
So courtship feeding, I do think I'm the first that documented that in humans.
So now I have a question that kind of popped in my head. And since this is all about sex to me, I'm not going to worry about the delicacy of the question.
Okay.
Are you
going to make me blush?
Well, it just might. It just might. So do women's appetite for types of food change with respect to where they are in their cycle?
That I don't know.
Okay.
I could not answer that.
Well, what
question.
about your history yourself?
Well, some people describe craving chocolate, etc., before they ovulate, but I don't have sound data on that. I do know that women's self-esteem goes up prior to ovulation and during ovulation, and in fact, because I interviewed these women at a rare moment in time that will never occur again. The sexual revolution, the quote-unquote sexual revolution, had happened. This was in the mid-'70s. AIDS had not yet reared its ugly head. Yeah. And so most contraceptive use was really pregnancy prevention. It wasn't so much and also everybody assumed, antibiotics will cure any STD that rears its ugly head. So I interviewed women about contraceptive use with their various male partners also, because I was curious. My assumption was that they'd be more risk-taking with sex with the man that they felt would make a desirable partner. In fact, quite the opposite was true. They became careful users of birth control only when they met a man that they would have liked to father their children. So birth control use was more a matter of timing than it was of anything else. It's not that they didn't want that. It's like they didn't even think of themselves able to get pregnant until they met a man who made them want to have children. So that goes back to the high self-esteem at ovulation, because I thought, gee, some of these women had what I called sex with jerks. Some of these women had sex with jerks and didn't get pregnant. Why is that? Why did that happen? I'm not advocating this sex with jerks theory of contraception. I don't want any of my kids or grandkids or great-grandkids to employ that method. But what I suspected might be happening was the high self-esteem that accompanies ovulation meant that women would be less likely to have sex with the jerk at the time they were ovulating. That's a theory, not been proven. See,
right.
I have a theory for everything, Len, but that one's not been documented. But the sense of high self-esteem during ovulation has been documented, as has cravings for chocolate and stuff. But I don't know enough about that.
That's fine. And we're gonna circle back to that in a later chapter. I mean, and so I'm going to kind of move the conversation along a little bit, but I'm still going to stay on the food thing, because you mentioned how I think it is with what the guppies, I mean, they dine on orange fruit. I mean, and so you say it's no surprise that the females find orange such as an attractive feature in the coloration of the males that they favor. So let's say something happened pretty dramatically, I mean, and oranges were no longer available. And let's say apples were available, and they're red apples, and so now only to survive, I mean, you need to consume red apples. I mean, do you think the color, I mean, of the features in the males they favor would change to red in pretty short order?
I'm not sure. I suspect that it might, but I don't know. And because I do believe, as you know, having read my book, that evolution can happen much more quickly than Darwin gave it credit for. That's one of my quarrels with Darwin, is that he believed it was very, very slow. Took large numbers of offspring. I think he's wrong in that. And one of the gentlemen I think I talked about maybe in this chapter or the next, who worked with lizards, documented how rapidly evolution can occur.
And I'll relate a story, about my past, with some respect to selection experiments, and there was a post-selection, sexual selection involved, although it was just, well, I shouldn't even say sexual selection involved, but it was male-female mating. So I did some research with a graduate student, his name's Ken Weber, and what we were trying to test is whether small populations would evolve more quickly than large populations. And at the time there were two schools of thought. One is that the small population, a mutation would be spread through, or variation, allele with a positive effect would spread through the population much more quickly because it's a small population. And the other theory was that, well, with the large population you'd have more variation, and so even though a positive allele would spread through the population more slowly, because you'd have greater variation, you have a better chance of allele that was even more beneficial arising. And so we tested for resistance to alcohol. And so we had a column of ethanol gas, and we put flies at the top of it. They just baffle so they could fall down. So the longer it took them to fall down, the more tolerant they were of the alcohol. So we would take the ones that fell down last, and we found our next generation on those. And so we had two different sized populations, one for 100 fruit flies and another one for 1,000 fruit flies. And it started off with the smaller population having a greater resistance. The way we measured the resistance was by how long it took all the flies to fall down. So we just take the average. The smaller population started off with a much greater resistance than the large population, but by the 25th generation, the large population caught up, and it never looked back. I mean, and so by like 100 generations, I mean, the larger population was so much more resistant to ethanol than the small
Oh, that's
population.
fascinating.
Yeah, it was a fascinating experiment. And so and yes, I mean, that's when I became really familiar with the Hardy-Weinberg equation, equilibrium, and clearly we were forcing it because we
They were in test tubes and so forth.
right,
Yeah.
right.
But still, it's a fascinating study. Yeah.
Yeah. And so yeah, it's just an indication of how quickly selection can act, but also the benefit of having a larger population versus a smaller population. Even though in the short run, it seems like the smaller population is better off. I mean, in the longer run, if you're really selecting for a given trait, the more variation you have, chances are, the more quickly the more variation you have, the more likely you'll get a really strong allele that's beneficial for the entire population.
Yeah, sexual selection is really good in that it hides some traits.
Right.
You know, that all the traits that are expressed are not all the traits that are available. And so it can adapt quickly. Sexual selection enables species to adapt much more quickly than asexual selection does. And there are some species. There used to be what is called the elm oyster model. Do you have any familiarity with that?
No.
I think both elms and oysters can switch between sexual and asexual
Right.
selection as a form of reproduction, depending on what the environment around them is.
Right.
So in times that are favorable, they go with asexual selection because they're already well adapted to that. But when times are tough, then they'll switch to sexual selection because more variety is available. And hopefully some of their offspring will have genes expressed that enable them to survive in that tougher climate. So that sort of relates to the study you're talking about with the fruit flies.
Right.
I find it all just completely fascinating.
No, I agree. And so it is interesting. So what you talk about in this one, where we had the event that led to the reduction in chromosomes in the great apes from 24, to current humans, 23, and you say it's like why you say it's a seemingly small change, and for me, I guess my background in biology is like that's a huge change, and so the reduction by one chromosome is massive.
It's massive.
And so you do actually point out, it's like, how is it then that chances are you wouldn't end up with a species or an entity that would be able to mate with another one and then produce fertile offspring.
Right.
And so you raise the possibility that other mutations, similar mutations, were happening at the same time because we were at a point where there may be lots of environmental background that was leading.
That's my speculation.
Yeah.
I mean, I obviously don't know, but that is a massive change. The whole notion of species is such a slippery definition.
Right.
I don't think we have a consistent and reliable definition of what a species is. My favorite definition, the one that I cling to, is different chromosome numbers.
Right.
For example, in some of the fish that evolve very quickly to different color variations, we might call those a different species. But in fact, they still have the same chromosome numbers, and if there's nobody else available, they can and do mate with each other.
Right.
So, and I know there are behavioral barriers to mating sometimes, such as a bird doesn't recognize the song.
Right.
But as long as the numbers of chromosome pairs are the same, I consider them the same species. But the species, we don't have a good at least not a hard and fast definition that satisfies me. And I once tried to raise the question with a bunch of mycologists who were talking about different mushrooms, and their reproductive habits are kind of amazing anyhow. And they laughed at my question. They said, oh, you're hinting at something. You're suggesting that our definition of species is a little slippery. I said, yeah. They said, you're right, it is. So yeah, that's, to me, that is the origin of our species.
Right.
This end-to-end chromosome
Right.
fusion. Almost overnight, we went from a species with 24 pairs of chromosomes, as all the great apes have,
Right.
to one with 23.
Right.
And that's the origin of our
Right, right.
species.
But it's
and
not-
it happened fast.
Right. But it's not necessarily a given, though, that they weren't able to mate, with the other.
It's hard to come up with examples of species that can mate across different
Numbers of
chromosome
chromosomes.
pairs and come up with fertile offspring,
Yeah.
or even come up with viable offspring. I mean,
Right.
you know, we're all familiar with the horse
Right.
and the donkey resulting in a mule. That's one of the species,
Right.
two species that have different chromosome pairs,
Right.
horses and donkeys.
Yeah.
And they are able to mate with each other and produce
Right.
viable offspring, but those offspring are themselves sterile. They're
Right.
not fertile. And of all the species, look at how few examples we have of that happening, of
Yeah.
cross-species mating that come up with viable offspring at all.
Right.
You know,
So-
most cross-species mating don't produce viable offspring
Right.
in most cases.
So then your hypothesis for why it might have been that the species was able to take off, the new species, was that there were other mutations happening. So you got like the same mutations, or at least mutations that created that reduction in chromosomes happening in multiple places. And what was the other possibility? All right, I don't remember, but
I don't remember
That's fine,
either.
that's fine, yeah.
But maybe even like mating back to the parents or within the family group. That I
Yeah.
mean, I'm just making this up as we
Yeah.
go along here.
But then it would
Len,
take-
where there'd be the same vulnerability. I do speculate, and I know this is true,
Yeah.
that not all chromosomes are created equal.
that was the other thing you said.
Yeah,
So
no,
that-
no. So some chromosome pairs are, or some chromosomes are more vulnerable to mutations than others, but most of them are the result of what we call non-disjunction,
Right.
like horizontal.
right.
But this reduction in chromosome pairs is the result of end-to-end chromosome fusion.
Right.
And that's much rarer because the telomeres at
right.
the ends of the chromosomes protect
Yeah.
that from happening. And there are some chromosomes much more vulnerable to non-disjunction, such as trisomy 21,
Yeah.
which results in Down syndrome. If it happens often enough, then the syndrome gets a name, but some of them happen so rarely because some chromosomes are less vulnerable to that kind of
Right.
what's called non-disjunction, where they don't cleanly separate.
Right. Right. So yeah, I guess maybe I can see what happens is that you have that end-to-end fusion happening frequently enough, and given the argument that you make later on, that people with similar genetic compositions are attracted to each other, you could get the species going that way. Because, all right, you know, I was just trying to get to us. I was thinking that we then, I was thinking, was there a bottleneck around that time also?
I don't know, Len, you
Okay.
might know that better than
No,
I
I
do.
don't. I'm really bad at that. Yeah, that was not my forte when it came to my work in population evolution genetics. I mean, it's like remembering the species and all of that. I was just really more of a DNA sequencer, and doing these kind of selection experiments. You know,
I just find it all so incredibly interesting.
Yeah.
It's not everybody's cup of tea, but
Right.
it's something that I find just fascinating to
Right.
try to figure, how did this happen?
Yeah.
And I am increasingly convinced that some of it happened rather rapidly, just like the whole Cambrian explosion that we hear about.
Yeah.
How do we explain the Cambrian explosion?
Yeah.
Well, guess what evolved shortly before the Cambrian explosion? sexual reproduction
Yeah.
as opposed to asexual
Right.
reproduction.
Right.
Sexual reproduction is just
Right.
evolution happens much more quickly
Yeah.
because of this scrambling.
Right.
Uh,
Yeah, exactly. Right. Recombination.
yeah, and
Yeah.
recombination.
Yeah.
So
Right.
that's just fun to talk about
Yeah,
with
I hear you. And as much as we want to keep going, I'm going to do the editors a little favor on this one, and we're going to end it a little early. It's, I think one of the last two ran a little long, so I'm going to end up. I'm going to sum it up, as you say. If I could sum up the difference between the 66 women that I interviewed and the ways in which men respond when I ask the same question, it would be that women come to see the men that they've come to love as handsome, whereas the men come to love the women that they have first perceived as beautiful. Eh, I guess that does sum it up.
And as I say in the book, that one of Darwin's mistakes is he projected the trait that influences male desire, beauty.
Yeah.
He projected that trait onto the women doing the choosing,
Right.
where in fact women choose for a whole range of traits other than physical appearance.
Right.
Once they've chosen for those traits, they see the guy as handsome.
Right.
But yeah, it's
Yeah.
fun.
No, it is.
Yeah.
And we're gonna continue the fun on chapter 3 in our next episode. So
Thanks.
thank you for a wonderful conversation.
Thanks, Len.